Okay, this is the fourth video of chapter 2. We're still talking about families. So this family is known as a noble gas. It's either 8A or 18. And you'll notice they all are gases. They were originally thought to be inert, but some of them can react with other elements if they're forced to. You can see they have different colors as they're lit up by electricity. They're very stable, but they do rarely combine with other elements. They really do have to be forced. So we also need to talk about some other families or other elements on the periodic table. Carbon itself is able to join with itself and other elements to give very many different things. Look at the different structures carbon can be. It can be like coal or it can be like a diamond. It has different structures that it can be. If it's made in flat sheets, it's graphite, and we use it in a pencil. Diamond, though, is very strong and hard to write with. A Buckminster fullerene, they're actually used to encapture medicines now to put into different places in the body, and they'll put little things on it. Carbon nanotubes, carbon fibers, if you've heard about that, they help make airplanes strong, and they've replaced the heavy steel beams with carbon nanotubes and carbon fibers. A Buckminster fullerene is what I was talking about earlier. It sort of looks, it is the shape of a soccer ball. It has pentagons and hexagons of the carbon in there. It's very strong. There's things that we can make all from batteries to inks to soles to tires. Lots of things that we can do with these carbon fibers now that we know how to make them. Capacitors, sensors, electrodes, catalysts, actuators, like I was saying, building blocks. So when we have an electronic structure, an electron is confined to a specific region on the nucleus or around the nucleus and given a particular energy. We call these shells or energy levels, and they're known as N. These shells are numbered 1, 2, 3, 4, 5, and those are the numbers that I had you put down the side of the periodic table. They're the rows. So 1, 2, 3, 4, 5, 6, 7. It only goes up to 7. Electrons in the lower number shells are closer to the nucleus and are lower energy. The ones in the higher number shells are further out from the nucleus and have a lot higher energy. So it's sort of like a shell with layers. So it's another look at it. It's more the Peach model, Rutherford's Peach model. So 1 shell out, 2 shells out, 3 shells out. And as you get farther out, each shell holds more. So the first shell only holds 2, the second shell out can hold 8, the third shell out can hold 18, the fourth shell out can hold 18 plus 14, which is 32, and it just keeps growing like that. Okay, the shells with larger numbers are farther from the nucleus and hold more. We talked about that. The maximum number of electrons in each shell is given by the formula 2n to the squared. So if I'm on the second shell out, 2 squared is 4, times 2 is 8. If I'm on the third shell out, 3 squared is 9, times 2 is 18. So you sort of see how that works. And we just keep getting bigger and bigger. Amount of energy going up and the increasing number of electrons. So if you haven't done it already, you'll be doing a POGIL, and this is to help you understand how things go into the nucleus, where the nucleus would be the ground, the floor of the ground floor, and then going up. All right, so we have electronic structure here. We have SPD and F shells, and the subshells consist of different orbitals. So the S orbit is a sphere, the P orbit is a dumbbell shape, the D orbit is the blues here, and they're like a clover leaf pattern on the different axes, except for this middle one, which is like a P, an elongated P with a donut around the center. And then you get to the F, which there's 7 of them, and they are 6 things going around different orbits, and except for the middle one here, which has 2 rings instead of 1. So it gets a little crazy, but each of these orbits can hold only 2 electrons. And the number of orbitals is stated right here, but you can sort of see how it builds like this, and you can see how it would make a more amount. So sort of like a triangle. All right, the next section here sort of tells us how things go together. So if I have one shell, it's the 1s, and we get a maximum number of 2 electrons. The second shell, we have 2s and 3 2p's, so we get a total of 8. the third shell, we've got the S, the P, and now we've added the D, and the D had 5, so now we're up to 18. The 4, same thing. Okay. This is where I want you to take time, stop this video, and color your periodic table. Put all this information on your periodic table so that you have it. So I'm going to stop the video right here. So pause this video so you can look at this, color your periodic table, and get what you need done.